Hey everyone, I hope you all are safe and doing good. So, in this lecture, we are going to discuss some basic building blocks of programming. That is, what are variables, keywords, identifiers, constants, literals, and we will do some practice exercise as well, right? So, this is the thing we are going to discuss in this lecture. Now, first is what are keywords in Java or not in Java? Keywords are in any other programming language also like C, C++, Python. In those programming languages also we have keywords. So, what is meaning of keyword? Keywords are basically reserved words, or these are predefined words having some special meaning to the compiler. Right now, what does that mean? See, we know when the signal is red, so you know you have to stop there. When the signal is green, you know you can go now. So the meaning we know, red light and green light, we know the meaning. This is universal. Everybody knows. These are predefined. Suppose on a gate it's written pull, so you will pull the door. If it's written push, so you will push the door. So meaning is predefined, right? It's like, see, if suppose I am head of my village, sarpanch of my village, then it's my responsibility to do some development task in my village, construction of roads and everything, to take care of electricity and water and all. So suppose I'm going to the work is going on for construction on the road for construction of the road in my village, and I am head of my village. So can I do this thing that whenever I put that signal or the traffic signal in my village, so for green light, it means you have to stop, and red light means you can go. It's specified, it's defined for my village only. Can I do that thing? Obviously not. Because green light means go, red light means stop, and these are predefined thing, universal truth. So we cannot specifically our village can do this thing. Like green means stop and red means you can go. No. So same in every programming languages there are some special words, and the meaning of those words are already defined to the compiler. Once compiler get that word in your program, compiler knows what is the meaning of this word, right? And when you declare a variable, obviously we cannot use keywords to declare variables. Like the example I have given you, we cannot again define for my village like green means stop, red means you can go. No, because they have special meaning. So those are keywords. Keywords are predefined, reserved words in Java that have special meaning to the compiler, and they cannot be used as identifier. This thing I'll show you practically also. Identifier also I'll tell you, like simple name of variable or any name of a class or name of a method. Those are identifier, nothing else, right? And so there are these many keywords in Java, 51 keywords. You don't have to remember all, but you can see many of keywords will be using in later videos. See, we have used this class keyword. So class is a keyword, and the meaning of this class is already defined, right? So compiler know once it will find out the class keyword means it has to define a class, and the next thing is the name of the class only. We will be using if, for, new, int, final, finally, float, else, double, break. These are all keywords. They are having special meaning to this Java, right? We'll be using this throw, throws, try. Once we will be discussing exception handling, super keyword also, final also, finally also. So you don't have to exactly remember these all right now, because in our programs will be using many of these, and you will be habitual of getting these things like, okay, this is the keyword, this is the keyword, right? I'll or you can also go to that. Let me just show you how you can. I'll give you a link also. On that link you can see, like in Java we are having these many keywords. Let me show you that thing. See, once you search Java SC specifications, this thing we have discussed in previous lectures also. Once you click on the first link from Oracle Java SC specifications, there you will get. We are not using 23, so you will not see this thing. We are using 21. So for Java language specifications, you can go to the HTML specifications, JLS specifications, and there you will get, see, written by James Gosling and many others. So there are many chapters, and there we have keywords. Sorry, these are identifiers. So these are keywords. See, there are 51 character sequence. So these words are 51. So you can check out this thing also, or the link I'll give you in the resources you can check out. So these are keywords in this JDK 21. Now, one more thing is reserved words. So, let me show you what are reserved words. Basically, reserved word and keywords are not exactly same, but we can say keywords are reserved words. But vice versa is not completely true. We cannot say reserved words are keywords because see, keywords are currently used in Java language and have specific meaning. But reserved words are those words which are reserved for future use in the language. Maybe we are not using those words right now in our language, in Java language, but we we kept these words reserved. Maybe in later in future we'll be using these words. So in JDK 21, these two are reserved words: go to and const. Right now in 21, these words are not in use, but these are reserved. I don't know about 22 or 23. Maybe they have used these words as a keyword. You can check out in JLS specifications of 22 and 23. Right. So I hope the difference is clear. There are basically students, get confused in these two words, keywords and reserved words. So like we have some money. So currently we are using some money, and the money we have reserved or we have saved for future use in bank account. So obviously, the money which is in bank account or we have saved for future, we are not using that money. It's not like that we will not use that money and anyone can else access that money or like this. No, we have reserved that money for our future use. Okay, maybe right now we are not using that money. Same, maybe we are not using. They haven't used this go to and const in JDK 21, but they have reserved these words for future use. And same, we cannot use these words as a name of variables or we cannot use these words as identifier, right? So keyword and reserved words are clear to you guys, I hope. There is nothing much about these things. Now next is variables in Java. What are variables? See, in the previous example we have seen, let me just show you that example first. See, this was the example we have taken, this kind of thing. So this is basically a class student which is having these three attributes: name, id and age, or these are known as instance variables as well, or these are known as like state of an object. And these two, the methods, these are known as methods, or we can say behavior. The state of an object is represented by the attributes, and the methods we have in that object, those represents behavior of that object. Right? So this is just a class, just a blueprint. Obviously, to use these things, we have to create object. So suppose we have created one object. The name we have given Rahul, ID is 100 and age is 23. Another name we have given, suppose like Jia, ID is 101 and age is 21. So like this, we can create many object of this class. This thing we have used. Now see, name is equal to Rahul. Name equal to Rahul. So to store this thing, we have used a name. I can a name. So this is a variable, nothing but a variable. In Java, we call this a variable. This ID is a variable. Age is a variable. So variables are like containers. They store some data values during program execution, right? Like see, we have our own brain. So suppose here I have written something like this. I have written something like this. Like 10, 20, 30, 40. I'll say just look at these numbers. Now I'm going to rub these numbers. Still you remember? Still can you do some of the numbers I have written here? Yes, you can do because you have your own brain. In your memory, you have saved these numbers. Without here, I'm not seeing any number here, but you know the number here is was 10, 20, 30 and 40. And you can easily tell me the sum, right? But this is not the case with computer. Computer is not having its own brain. Yeah, obviously computer has memory, but to store something in that memory, we need variables to hold that data in computer memory. You need something. So that something is known as variable. It's like a container, right? So we give it a name, maybe A, B, C, D. And in ABCD, the values are stored in the memory. So this is A, this is B, this is C, and this is D. So here we have like 20, 30, like this. So A is just a container. Name of this container is A, and the actual value is 10. Okay. So in computer memory, we can say, in other words, we can say variable is a named memory location which stores some value. You got it? Now, it's not like that these every container is having same size. See, now what kind of value we can store in variables? See, in name I'm storing Rahul. I'm the name, the string. We can say that's a string, literal. What is literal? I'll discuss later. In ID, I'm storing 100. So this is simple integer value. In age, also simple integer value. Or maybe some other thing also. Suppose I am having marks. So there, suppose 98.99. So this is decimal value. So we can store different kind of value. It's a textual data as well, or a string we can say, or a integer value, or a decimal value. Different types of values we can store. So how this thing is determined, which kind of value is stored in a variable, with the help of the type of that variable or the data type of that variable. See, the data type of name is, we take is string. There are many types. We will discuss data types as well, in which we are going to store this integer value. So for that, data type is int. If we are going to store this decimal value, for this data type is float. So there are many data types. I'll discuss every data type. So basically, what kind of value you store here, that is determined by the type of that variable, right? And every variable is of different size. See, in your kitchen, it's not like that the container you used, your mother used in your kitchen, is of same size. Not at all. You can go and check and ask to your mother, like, why there are different size of containers. If you want to put, like, for containing those spices, maybe turmeric, coriander powder, or red chili, the container are small, right? And for some, suppose I want to put rice, so for that container is, I guess, a little bit big. To just put some, like, cardamom, the container is maybe very small. And in which I have atta, flour, for that we have a drum. Means we have a drum. I don't know what you have. This is like drum, so this is very big. So in our house also we have different size of container. Like, this is my lip balm. So for this, the container is, see, it's so small, right? It's not like that in our kitchen I have the container, the drum, or in there I can use this lip balm. Definitely not. It's just wastage of the space. Definitely. Because I'll not be using that much lip balm. This is fine for a lip balm, right? Or maybe like for Vaseline, I have this kind of container. This is a little bit different in shape also, as well as in size. So in real life also, you see, you use different type of containers. Like for moisturizer, I have this type of container. So in real life also, we have this thing, right? And why different size of container, that also I'll tell you when we discuss data type. But to somewhat it's clear to you why we use different types of data types, different types of container. You can ask your mother also that why don't we use same size of container in our kitchen to store everything. She'll tell you better, right? So same variables are also of different size, right? And that size is determined by the data type we use. And also, the data type determines what type of value would be stored and the size of that data to be stored. These two things, right? Don't worry, we'll see data types later. Okay. Now, I hope variable is clear to you guys. These are containers just to store data values during program execution in the RAM memory. Because obviously in program we are using variables. When you write program, you use variables, int a, int b, int age, float marks, and these type of variables. Many type of variable. So when you run a program, then the program would be loaded into which memory? RAM, which is volatile memory or main memory, primary memory. So We use data value, we store data values using variables during program execution. Means the data values are stored in RAM using variables. Right? Now, let me show you some that PPT. So, see, variables are containers that save data values during program execution, meaning the data is stored in the RAM uh, using variables, right? Now, I have told you variables act as a named storage locations in computer memory. These are simply, you can say, named storage location because the name of that location is the variable name. The actual value we store is maybe it may be a string or it may be integer or it may be decimal value or character value or anything. Okay. But basically, the name of that storage location is the variable name. How to represent, how to declare this thing, I'll show you. I'll show you. Why we need variables? Obviously, for data storage, variables store information or we can use for later use in the program. So, for need variables, because we can remember the things or the numbers because computer cannot remember because computer is not having its own brain. Code readability. Now, generally, we take variable name like int age or student age. So, from the name itself, we come to know that it's age of a student, this variable, right? So generally we put a descriptive names, a meaningful name, right? Like float marks. So by looking at the name itself, we can determine, okay, this variable is storing marks of student or marks of anyone, okay, or name. From the looking at the name of the variable name, we can see that yeah, this variable is having name of any student. So it will increase the code readability. And obviously, variables allow for easy modification and calculation of data. We use some calculation, we do some calculations also using variables. Now, real life example also you can take like storing current temperature readings in weather applications. In racing game also, to track the vehicle speed. Item count in shopping cart. Once you add the item, that the cart, the number would be increased 1, 2, 3, 4. So that is like a count variable. Okay, in online shopping cart. So how to declare variables? This thing, let me just show you where how to declare variables in Java. And I'll tell you the difference also, declaration, definition, and all. So basic syntax is what? We just write down here the type of the variable, or you can say the data type of the variable. Then we write name of the variable simply. And this is also done. But if you write down the proper syntax, then here we write, here is equal to, you can assign any value or more precisely directly write it. Don't write down like simple value in technical terms. Or more precisely if I say, then we write here literals or expressions. Don't worry, we'll discuss what are expression and literals also. But these things are optional. So that is why we put like this and semicolon. So this is proper syntax of variable declaration. Now what is this type? The data type we use: int, float, string, boolean, character, or whatever data type that we write here. Like if you want to suppose declare an integer variable, we will see all the data types, but right now you know integer data type, so I am using int and float only. So simply write here int, the data type, the name of the variable name, suppose I'm writing student age, right? If you simply write down this thing, this is simply declaration, or we can say definition. See, there are two terms here. Many students get confused in these two terms: definition, declaration, and all. So let me just first clear this doubt of yours. Declaration means simply we are telling the compiler the name of the variable and the type of the variable. No memory allocation. No memory allocation during declaration. So no memory would be allocated in the in this computer memory for that variable while declaring that variable, right? Definition means we are telling the compiler type, the name of the variable, as well as memory would be allocated at that time only. Main difference is this. Main difference is this. But now, by looking at this, what do you think? Memory would be allocated. Memory has been allocated or not? Yes, memory has been allocated here. Because this declaration is what? See, its declaration is not a concept in Java basically. It is definition. At this time only you write down any value or not, you initialize this student age or not. Memory has been allocated right now. Integer take 4 bytes generally, like in 64-bit machine or recent machine. Maybe it depends on your machine also, but generally it takes 4 bytes. You can check the size. So memory 4 bytes has been allocated to this. Now what does this declaration means? This concept is in C basically. See, in C, maybe if you haven't heard this thing, don't worry, you can leave it. There is a word extern. Extern int A. So this is declaration. At this point of time, no memory space has been allocated to this variable. Extern means it has been defined somewhere else in different file. And we are using that variable in different file, in different C program. Have you used this concept before? Like we have this extern scope, also extern variable, global scope and all. But if you haven't used this, don't worry. This extern means this thing means we have this variable defined in some other file and we are using in some other file. So once you are using this variable in that other file, at that time memory would be allocated. So if you are using this extern keyword, in this case only its declaration means no memory would be allocated. But if you write simply int A in any program, it means memory would be allocated. This is definition. But this concept extern is not in Java. So there is no such kind of thing like declaration actually. Every time it's definition. Memory would be allocated if you write simply like this. I hope this difference is clear. Now two terms are more, assignment and assigning a value to a variable and initialization. This thing also I'll show you. I hope this difference is clear. So don't worry, there is no such kind of thing declaration. Always if you write this thing, memory would be allocated, and generally everyone say that it's variable declaration. Because if but more precisely, declaration is this thing, but there is no declaration definition all different in Java. It's only space would be allocated. So generally you can call it variable declaration also, don't worry, it's okay. But actual meaning I have told you. Right. Okay. Now let me just show you one more thing. Now, what is this literals and expressions? So if I write here something like this, rather than this, if I write here student age at this point only I am writing here is equal to 21. So this 21, this value, this is a literal. It's a constant fixed value, right? So this we generally it's called as literal. It's integer literal. 20, 21, 22, these whole numbers, so these fixed value are known as literal in Java. Literals in Java. These are you can say that integer literal. Okay. Now this proper complete statement, this is known as initialization. Initialization means at the time of declaration only you assign value to that variable. This is initialization of a variable. Second is, one more thing is assignment. So if I take, note this thing, if I take something like this, suppose int, if I take id or roll number and id is equal to 100, this is known as assignment, or assigning a value to the variable using, this is operator, assignment operator. We'll see what different kind of operators, but this assignment operators will do whatever at the right hand side, the value that would be assigned to the left hand side, the name of the variable. So this is assigning a value to a variable or assignment. This is not assignment, this thing is initialization, because here we are declaring proper data type, name and then value. Here we don't have any type. Already we have declared this variable or defined this variable here, and after that I'm assigning this value. This is assignment, but this is not possible every time. I'll show you the cases when this thing will not work. This thing we cannot do with instance variables. Instance variables, I've told you, those class level variables. In a class, we have taken int roll number, int age, student name. There, we cannot assign a value something like this. For local variables, we can assign. I'll show you practically what are local variables and all. So the cases I'll tell you when this assignment will not work. Right. So I hope the difference is clear. Declaration, definition, initialization of a variable, and assignment of a value to a variable. What are variables? Now, next thing is why these are called as variables? Because the value you assign here, that can change. Suppose I have assigned a value int student age is equal to 21. Now at next point of time in my program, I can write something like this: student age is equal to 23. This is fine. So I can change the value. At first, student age was having 21. Right now, student age is 23. That is why it's known as variables. I mean, the value can vary. The name is variable, right? And we can access these variables by its name only. If system.out.println, you simply write this name of the variable, it will give you the value. So just have to tell the compiler the name of the variable, and it's the headache of compiler. The compiler will search in the memory where is that variable, and it will show you the value. You just need to remember the name only. In memory is something like, memory is simply, you can say, it's a long tape of bytes. We are having in memory cells. Each individual cell is representing a bit, either 0 or 1, right? Something like this. A long tape of bytes. This is memories. Somewhere, someone represent this vertically also. These are the blocks. Someone represent this as in horizontal form also. Somewhere you will see like this kind of block, and here we have like this kind of thing. These are blocks in memory cell. These are memory cells, something like this, right? So just in any way you can represent, because we have to just visualize this thing. Actually, we don't know how the memory is stored or looks like in computer, but we know this thing, that memory is having many memory cells, and each cell represent a single bit, either 0 or 1. 4 bits form 1 byte, and then different word length also, 8-bit length, 16-bit, 32-bit, and this kind of thing. Okay, that is a different concept. Now, see here we have int. Int means the data type tells the compiler that it is the name of the variable, and int means 4 bytes would be allocated to this variable. So here 4 byte means 4 into 8, 32 bits. So like this, 32 bits would be allocated to this variable student age. So like this, suppose from here and till here, we have, these are 32 bits, total in 32 bits. So the name of this would be given student age, and this data 21 would be converted into obviously first zeros and ones, and that would be stored here, 21. So rather than representing this each individual bits and all, we just, for a sake of simplicity, we represent something like this: just one block, and there 21 has been stored, and the name of this variable is student age. That's it. And obviously this will having some address. We don't know the address, that would be in hexadecimal form, but suppose for simplicity purpose to understand this thing, let's suppose address of this variable is 1000, but actual definitely not 1000, it would be in some hexadecimal form and all. Okay, so suppose address is this, name is this, and value is this. So just a named memory location. We simply access the value using the variable name. We don't have to remember, we don't know where this is stored, the address and all. This is headache of compiler. Compiler will search in that thousands of cells in the memory. Where is this address? And what is the value? And it will give you the value. See how smart the compiler is, right? So you can access variable using the name itself, right? Now there are types of variables, but those things we will discuss with the help of practical. I'll show you right now. But before that, there are some naming rules for variables. And what are those naming rules? Means you cannot, it's not like that, just put any name. No, there are some rules to name a variable. So, what are those rules? Let me just show you those rules here. This simply initialization and declaration and all this thing we have discussed. This slide will discuss practically what a type of variable, local, instance, and static. Okay. Now, first see the naming rules for variables. So, variables contains alphanumeric value. Alphanumeric value means either alphabet A to Z or capital A to Z or numbers from 0 to 9, or two special symbols are allowed, dollar and underscore. These things are allowed in the name of a variable, right? Variables are always case sensitive or start with a letter. Must start with a letter, either this or this, or can start with dollar or underscore, but cannot start with a number. This thing is not allowed. Variables must begin with a letter or dollar or underscore. Variables are case sensitive. Case sensitive means if I write age and if I write age, these two are different variables. Here A is small, here A is capital. Java is case sensitive. Next is no keywords are allowed. Keywords, I have told you there are 51 keywords in Java. So those keywords are not allowed. We cannot simply write like int, and again I can write a like class, because class is a keyword. So this will give error. You cannot write int. Name of the variable is again int. This is a keyword. But you can write this thing int and int. Because Java is case sensitive, so this thing is allowed. Capital int, this is not keyword. Small int is keyword. But you should not take these kind of name of the variable. You should avoid. Name should be descriptive. Should not be matched with any keyword. Descriptive means age or student age would be better than simply age. Marks or student marks would be better rather than writing simple int a and having 21. Better to write student age 21. So that by looking at the name of the variable, we know that this is name of the variable. No white space are allowed. Means in a name of a variable, white spaces are not allowed. If I write student age something like this, student space age int, this will give error. White spaces are not allowed. Camel case, use camel case for multi-word keyword. Camel case means something like this. No white spaces there here. Student age. Camel cases first should be small and every other word the first letter would be capital. So this is lower camel case basically. It's not rule that you have to do the thing, but it's just a convention. They have said, the makers have said that this is a convention. Everybody should follow these rules. Okay. To make their program good, and you know, it's always better to follow the conventions, right? Now let me just show you some variables. These are valid or not. See, these are valid variable names. Age. Here I have dollar. See, dollar price. This is valid. Variable name can start with a dollar. First name valid. Roll number. In between I have underscore. This is valid. At first we have underscore. This is also valid. Count one. Sum 1 to 3 digits are also allowed. So these are valid variable names, right? Now some invalid variable names are 1 to 3 ABC. At starting, digits are not allowed. First, hyphen name. Any special character uh, rather than those dollar and underscore, not allowed. Hyphen is not allowed. Class, it's a keyword, not allowed. My variable is having space between these two, not allowed. So these are some naming rules for variables. Now let's discuss not constant first. Let's discuss the slide. Types of variables. I hope basics are clear. I'm going a further deep. We can skip this also. Types of variable, it's not that much like required. Generally, you will not get this thing right here. Types of variable node. But I'm going to cover in deep. Whatever you will not get anything, you will get, in this course. So we'll go a little bit deep. I'll discuss what are local variable, instance variable, static variable. So stay focused and try to understand. If you need a break, you can pause the video, take some break, and then come. Okay. I just hope ki things will not be, overwhelmed for you guys. Just don't feel that, ma'am, we are what you are talking and we are not getting anything. I just want to give you a, we are discussing variables, so I just want to give you a deep kind of thing, deep intro. I know to this extent you can understand, but I'll not go into that much deep. It's okay. You will understand these three types. So let me just show you these things with the help of example practically. Till now, whatever we have discussed, let's do practical. Then we'll discuss further, right? So let's open our IDE, IntelliJ IDEA, or you can use any other IDE as well, or you can go for any text editor also, Notepad also. There also you can write code. In the terminal, you can run with JavaC command and you can with compile with JavaC command and run with Java and the class name. So here in our first project, we are having in SRC, Hello Jenny, power of two, three files we have, right? So rather than these three files, let's create one more file now, one more new class, Java class, and the name let's take simply student. So this thing you will get automatically public class student, and see you here, you see opening braces here and closing braces here. Many programmers developers do this thing, but some follow this also. The opening braces here, closing braces also here. But generally, this is the convention. You can follow any one of these. There would not be any error kind of thing. But this would be followed generally by the programmer. So we'll follow this convention only. Now in this class, let's take a simple example because we haven't discussed till now the data types and all. So we'll not go into that much deep, or we will not take different type of variables. We'll take some simple variable that is integer, because everybody knows integer. What is integer, right? The whole numbers. Int, and I'm just taking, let's take roll number is equal to, suppose roll number is 22. Simply I'm taking this thing, one variable only. Roll number is the name of the variable, int is data type, and the value is 22. Okay. Now here let's take one method display. Method is simply, or you can, we follow this also, this extension and this convention. Method is simply like the functions. Functions are having, within this we will be having maybe different one or more instructions, and that would be executed to perform some specific task. Those are functions or methods. We'll see these things in detail, but here we will simply write down here one statement. So how to define these methods? Simply the data type. Void means it will not return anything. Display is the name of the method, and you have to write down these braces, opening and closing round bracket. So this, and then opening and closing braces, these braces. Here we write down body of the method. So this is simple how we define a method or a function. Here we don't call this function, these are methods, because these are, you know these are bound to this particular class student. These are not free floating in the program. It's not like that anyone can access and these are free floating. No, that's why we call this as methods, and this is known as attribute. We call these as attributes. Sorry, it's attributes. And one more thing we can call is that these are instance variables. I have told you types of variables, or class level variables, instance variables or class level variables. Because just after the class, outside of any method, I am declaring these variables. I am initializing this variable. I am taking this variable. So this is instance variable or a class level variable, right? Or whatever variable or attribute you take, those are also known as state of the object. These represent state of the object, and methods represent behavior of the object, how the object behave. Like my state is my name, my roll number, my age, or whatever attributes I have, my color, or these kind of things. And my behavior is, or my methods are, what I can do. I can teach, I can dance, I can sing, I can cook. So these are my behavior. This show my behavior. So methods show behavior of an object. Now in display, simply I will not write anything complex, just system.out.println, and I'm simply printing the name, sorry, the roll number of the student. Okay. Roll number is, and here we write a plus symbol and simply the name, roll number. This is how we print something. See, whatever you write in double quotes, that is what a string literal. So that would be exactly printed on the screen. Now, plus is addition for addition. But here, plus means concatenation. When we use plus here in, with strings, it means concatenation. Concatenation means whatever is there on the right hand side, that is roll number, name of the variable. So value would be taken from here 22. Whatever the value here, that would be appended to this string. That would be appended to this string. So first the string would be printed, roll number is this, and after that roll number, whatever the value of the roll number 22, that would be printed. So this, in this context, this plus meaning is concatenation. It's not just addition. Okay. Now obviously you have to uh, call that, you have to create that main method also to execute this class, otherwise the class is of no use. So either you can write down within the same class a main method, or you can take another class, any other class, and you can write down main method there. That is also fine. But right now, what I'm doing, public static void main. Within the same class, I'm taking main. You also just practice this with me. Okay. String args. This is the body of the main. And now I've told you how to access the members. These, all these things, attributes and methods, all these things are known as members of a class. So you can access these members using the object of this class only. You cannot directly access. If static variable or static method is there, then you can access without creating the object of that class. But these are not static. So let me just show you what error you will get. If you print something like this, system.out.println, and in main I simply want to access whatever the roll number is. That's it. So it will give you error. See, it's red. Without running also you can see, you can hover the cursor here and you can see obviously this error, this semicolon. But again, non-static field roll number cannot be referenced from a static constant context. If I run this, let me just show you the error. See. See now. Non-static variable roll number. Variable is, this variable roll number is non-static. It's not static. Cannot be referenced from a static context. Because directly without name of a class, if you want to access, then that thing, that variable or that method should be static. Otherwise you have to create object. If suppose I write here static, in that case, if it will not give any error. Let me just run this and I'll show you what thing you will get here. C22, it's running, it's not giving any error. But it's not like that for every variable and everything we use static. No, we will discuss about static, final, these keywords later. But this is not at all a good idea to make everything static. Just delete it. Generally we take these variables. So this is instance variables. Okay, now to access this, we have to create object of this class. How to create object of a class? Just name of the class, that is student. Object name, suppose I am taking obj or any name you can take, is equal to new keyword and student. This is basically default constructor. Name of the class with these round brackets. This is constructor. As the name is same as class name, so this is constructor. And no arguments are passing. This is known as default constructor. This thing also we'll see in constructor. But for this point of time, you have to remember that this is the way to create object of a class, right? obj, this is like an object of a class student. So if you want to access this roll number, so you can write down here obj dot roll number. And if you want to access this display this method also, then you can simply print obj dot display. That's it. What output you will get? Pause the video and think, and then run. Let's run this and I'll show you what output you will get. 22, roll number is 22, two line. Because at first, control will go to here, I mean the JVM directly execute this main. There, second line is to create object. System.out.println means whatever the value of roll number that would be printed, then it will call display. Now control will find out where is the definition of this display. Obj.display. So let's call this display here. And it find that there is one line, roll number is, and it will print 22. Right? Okay, so this is simple variable. Now let me just show some extra thing here. Now see, let me show you this thing. If let's suppose do this thing only in roll number, and here let's assign roll number is equal to 22. This will not work because this is instance variables. These are class level variables. Okay, these are not local variables. Local variables are within any method. If you declare any variable, those are local variables. So if within this method I take like int a is equal to 23 or int a is equal to 45, this a variable, this is local variable, local to this method, right? But these are instance variable or class level variables. Every object of this class can use these variables, instance variables, right? Now this variable can be used within this method only, int a. Outside of this method, the variable is of no use. Okay, these are local to this display only. Now let me just show you this thing also. See, it will give you error here at this point of time. I have told you assigning a value something like this to an instance variable is not allowed. It will give you error. Let's run this and see what error you will get here. See, Java identifier expected in third line. See, in third line, Java identifier expected. So identifier means any name of a variable, class or method is identifier. So here it is showing like a known class roll number. So you have to give here like the type of this. So like this assigning is not allowed. So let's just delete this and let's assign the value here, that is 22. But here the assigning is allowed, assigning of a variable. Suppose I'm not assigning int a, something like this, and a is equal to 67 or 45 or any. This one is allowed. This is assigning. Or in system.out.println, if you want to print this a, so we can simply print a is equal to and same plus and a. So it will give you the value. Rather than here, will not print here obj, we just call this display. So let's run this and I'll show you what output you will get here. First it will print roll number 22 and then a is equal to 67, right? Okay, assigning is done. Now initialization, this is initialization. At the time of declaration only we are initializing, but re-declaration is not allowed. Or let's just show you re-initialization. At first suppose it was 56 and again I have changed the value, a is equal to now 67. So we have re-initialized this value and that is it becomes now 67, or suppose it becomes now 78. So the recent value or the updated value it will give is that is 78. So we can change the value in the program. This is what, that's why it is known as variables. Next thing I want to show, that is this is simply literal, integer literal, any fixed value, these are literals. Expression also I have told you when we were seeing the syntax, then there I have written the type, name of the variable equal to literal or expression. Expression is simply a combination of some operators, operands, variables, and those evaluates to a single value. See, these are fixed value, no evaluation would be done. But for expression, some evaluation would be done. Suppose I write here int roll number is equal to this, and then int next roll number is equal to whatever the roll number plus 1. So this is expression. This needs some evaluation. Some evaluation would be done, and then it will give a value. So expression evaluates to a value. Roll number 22 plus 1, that is 23. Now 23 would be assigned to next roll number. You got it? If you print here this next roll number is plus and whatever this next roll number, the name of the variable. So let's not print this A. Let's just print roll number and next roll number. So it will give you roll number is 22, next roll number is 23. So this is expression. Okay. So here rather than this, we can do something like this also, like A is equal to this A plus 1 or A plus 2 plus some expression 5 into 7. Some complex expression also we can use. So what the value would be? Suppose right now A value is 1 only, just for a simplicity purpose. A1, so 1 plus 2 is 3, 3 plus 7 into this would be, I think, 35 and 38. Let's just print A value and see what output you are getting. See, A is 38. So at right hand side, we can use any simple fixed value, literal, or we can use any expression as well. Expressions are also allowed. So it's not like that simple value we can add. That's why I have told you this is the proper syntax. Type name equal to literal or expression. And this is optional. It's not like that you have to compulsory write down here the value. You can simply here write semicolon, and here now here you cannot use this value A because you haven't defined this value first. So rather than A, you can use here 3 plus 2 and something like this. So this is allowed. But here the assignment is not allowed something like this because this is instance variable. And static variable, I have told you, static variable means if you declare it's a, or one more variable, let's declare that is static, and that is static. And static variable, generally we declare those things static for which we want like some default value would be initialized. Default value for static would be 0. So suppose static and int and any other thing I am writing, like maybe a variable name x. That's it. So see, we haven't taken any value, but still if you want to print here, suppose let's print here in main obj.x simply. Let's just don't call this. One thing I'm printing obj.x. Let's run this and see what it will print. See 0 because we haven't assigned any value to this. Okay, so by default 0 would be assigned. If without object name, if you access this, then also you can access this. Let's run this because this is static variable. If variable is not static, then we cannot access. It's 0. Right? So this is static. So class level variable, basically generally some variables we can make static. We will see proper what is static, what is final at all. Don't worry. Now let's do one more thing. Let's not make it, let's just delete this variable and just don't. We are simply taking int roll number. We are not initializing this. And we are simply printing this. We are simply accessing this value. Obj dot roll number. What do you think? What it will print? See, we haven't initialized this here. We are simply printing this obj dot roll number value. Let's run this and see. Okay, I cannot find the variable next roll number in class student into L. Fine, you are using here next roll number, but here we have commented out this thing. These are comments. These are not to be executed by compiler. So if you think that, if you want that this particular line would not be executed by the compiler, just put these comments double slash here. So let's just comment, let's just remove the comments here. Okay, now you will not get any error, I hope. See, value is 0, right? Although we haven't initialized this roll number at this point of time, but still it is 0. So by default, I have told you the value of int is 0, but only instance variable in only in case of instance variable. If you take int a here and I don't assign anything, let's just delete this line. Or rather than delete, let's just comment this. Okay, let's just comment this. Now I want to print this a. See, it will give you error. You can already see a red line. Variable a might not have been initialized. Let me just run this and I'll show you the error. Variable a might not be initialized at line number 11. Line number 11. So the thing is, because a is local variable, so local variable will not get any default value. Compiler will not initialize any default value to local variables. Okay, you have to initialize these first before using these. Or if you don't want to initialize, you can assign a value after that. A is equal to 6. This is assignment. Before using, you can assign a value. Now this will work fine. This will not give you any error. So I hope this default value thing is clear to you guys. When the variable will get default value and when the variable will not get default value. 6 is not going to be printed because we are not calling this obj. Let's call this obj. We are not calling this display function. So let's call this and show you. A is equal to 6. Right? So local variables will not be initialized by default by the compiler. But instance variables are initialized. And default value for int is 0. Okay. And one more point I just want to clear here. See, while you are writing a class, while you're defining a class, so I have written here int roll number and this. So at this point of time, no memory has been allocated to this roll number. Now, maybe you think that, ma'am, you said in Java it's definition, so memory would be allocated. There is no declaration, although it's definition. But the thing is, because this class is simply a blueprint, if you do not create any object, then what is the use of this class? How memory would be allocated to these things? This is just a logical thing, just a blueprint. Like I've told you, map. The map is simply a blueprint. There is no space, there is no land you require for that map. If you have a map, you cannot say that I have 10 buildings and this is the map. Where is the actual building? Where is that land? You haven't paid something. But when you want to construct, then you pay, then you buy that land, and then you construct your building using that map. And actually, at that time, you are constructing your building and then you reserve the space. You have that land. Now you can say that, yeah, I am owner of this building. I have the space. Okay. Same with class. Class is just a blueprint. Without creating object, these are nothing. If you want to do something with the class, you have to create object. And while creating object, memory would be allocated at this time. So in roll number, no memory would be allocated for this at this point of time. When you create object at that point of time, memory would be allocated. I mean, basically this new keyword, when you use this keyword, then memory would be allocated basically. Right? So try to understand this thing logically. This is just map. No land is there for this roll number. This is bedroom. So no space or no land is there for this bedroom until and unless you create a building. So this is, I'm creating the building. I'm constructing the building. And now my bedroom has a space or a land. Right? But the thing is static. If you take something, some variable static here, at this point of time, you can see without creating object of this class. I don't want to create object of this class. So let's comment out all these lines. and let's just access the name of the static variable is int x, right? So let's access this x here. What do you think? Everything is, suppose everything is commented. There is nothing. In this, I have simply public class, student, a variable, static variable int x, main function. In main, I'm just printing x. No object, nothing else. Now, see, what do you think? What output you will get? Now, maybe you will give this logic. Ma'am, you said no memory would be allocated unless and until we create an object of this class. So, obviously, there is no memory for this x. Then how this x would be printed, right? Yes, the logic is right. But there is one thing for static members. For static variables, memory would be allocated when this class is loaded only. If you don't create any object, still for static only. This is the power of this word static. For static, memory would be allocated and 4 bytes would be allocated. And by default, x is 0. By default, x is 0. For all the static variables, this would be initialized with 0. The value would be initialized. The variable would be initialized with 0. So without creating object, you can access this x and you can see that you will get an output 0. That is, you can see the beauty of using static keyword. We will see later in detail what is static and all. Because for accessing static variables or static methods, you don't need object of any class. And if you don't need object of any class, then obviously memory would be allocated. If you create object or not, memory would be allocated, value would be stored. By default, 0 would be stored, initialized by the compiler itself. And you can simply access this thing. So this is one more difference between instance variable, local variable and static variable. Right? I hope you got this thing. So you try out, you practice different things. Right? Now suppose I want to take a variable int and suppose class. It will give you error. See, public class student. So what is this class? It's a keyword. We cannot use this for a variable. Class is equal to suppose a variable integer value I want to store 8. Let's create an object of this and let's obj dot class. Let's run this and see what error we are getting here. Identifier expected in 3. So it's not like proper given identifier or name of the variable. We cannot take this. But if you take class, C capital, what do you think? C is capital here. At this point of time, you will get 8 value. 8 value would be printed C. But it is not recommended to use the keyword name just by modifying this with capital and all. It's not recommended. You can use, but better to not use. Simply use a descriptive variable name, int, age, or anything you want to take, or maybe count or anything. Or this underscore count is also allowed. See, you can simply access here underscore count, underscore count. Class is not there. This will also print. So now you try out. You have the rules of the variables. You try to apply all the rules of the variables. Try to use keywords. Try to use dollar, space, and all in these keywords and use these. Okay. Now next, let's discuss the next concept here. So this slide types of variables I hope clear to you guys. Local variables declared in methods or maybe constructors or blocks have limited scope. Block means opening braces, closing curly braces. With it, this is known as a block. If you declare a variable within that block, the scope is within that block only. Means we can use that variable within that block only. This scope and all we will see in later videos in detail. Instance variable, non-static variables declared in class outside any method. These are class level. We don't declare instance variable within a method outside. Static class variables declared with static keyword and shared among all the instances. If you write static keyword, then that is like static variable. I have explained the difference and all. Okay. These are local variables. Int count is equal to 0 inside a method. This is instance simply string name. In a class outside method, static final double pi value is this shared constant. Now what is this final? This also I'll tell you right now in the next slide. Okay. Naming rules we have discussed, valid and invalid variable names. Now what are constants in Java? See, you have seen that thing. You have seen that thing here. See this thing. Final variable name was static, final, and then this was double, then pi, and the value is 3.14, something like this. Right? See. So constants are basic variables means once you assign a value to those variable, you can reinitialize those variables during the program. You can change the value. That thing I have shown. I've shown you. Constants means if for some variable you want that, let's just fix the value at first, starting of the program, and during the complete program, during the till of the execution, this value should not be changed. Anyone cannot change the value. You just make that thing, that variable constant. So constants are simple, these are variables whose values cannot be changed once they are assigned. Right? They are declared using the final keyword. Now, this final keyword is the one which makes this is simply the type, double is the data type, pi is simply the name of the variable, this is simply the value. One thing that is different from the one we have discussed, variable declaration, is this final keyword. So, this final keywords make this variable a constant. So, this value of this pi cannot be changed during the program execution. Right? So when you want to store fixed values, then we use constant, like this pi value. We know this pi is fixed. It's not like that somewhere in the program pi would be 2.14. No, pi would be fixed, right? Some configuration settings or mathematical constants like pi, or some commonly used values like days in a week. We know 7. So this we can fix at starting of the program. Some max value if you want to use in your program. So let's declare max value is equal to 100 or 1000. Max value cannot be less than this, cannot be greater than this. Or suppose let's one example is in banking account. There is one thing that is minimum balance. Minimum balance should be suppose 1000. So let's make in that application this constant. Minimum balance should be 1000 in your bank account. Otherwise, maybe some penalty or some kind of thing happen. So for these, if you want to fix some values, then we use constants. We generally don't use constants. Okay. How to make a variable a constant? Use final keyword. Now it will increase the code readability and maintainability because as the values purpose is evident from its name. Because see, days in a week, we know this is like number of days in a week. By looking at this, we can know that this is okay, days in a week. Or by looking at the name, we can know that okay, this is maximum value of something. So this is going to make your program more readable and maintainable. Okay. Now we can use this constant wherever you use regular variables such as in calculations, comparisons, or method arguments. Anywhere you can use this pi or this max value or this days in a week. In any calculation, in any method argument, or see in any comparisons also. It's not like that if you made this as a constant, then you cannot use in your program. Anywhere where you use a normal variable, you can use a constant as well. But the fact is that the difference only is what? Variables can be reinitialized. We can change the value of those variables. But constant value, once you fix that value, you cannot change the value during the program execution. You got it? If you want to change the value of the constant, at starting, suppose I have declared minimum balance is this. And suppose in my program, at 10 places or 100 places, I'm using this variable min balance, and this is constant. This is like final, and this is like long, or suppose int or any data type. At 100 places I'm using this. So if you want to change, the value of this min balance, so you don't need to change at the 100 places or the 100 times you are using in the program. No, you simply change here. Suppose balance I want to make 10,000 minimum balance. You just change this here, and this would be reflected everywhere in the program where you are using this variable. So this is going to increase the maintainability also, right? One more thing is what? Yeah, during the program, like anywhere in the program, suppose this is like from right from this is, suppose I'm writing the program and here I want to change the min value. So suppose min balance is equal to, I want to make 20,000. You cannot make this. This will give error definitely, because this is constant. Simply you can change here only if you want to change. At first, where you have initialized this constant, there only you can change. Otherwise, in the program, you cannot change. So it will restrict someone else to change your constant values. If you want that this should be fixed, and if some other person is reading your code or using your code, so and you want to restrict that person that this value should not be changed, so make that constant, right? Let me just show you this thing practically. So let's make only this keyword final. It's final int underscore count is equal to 8. Okay. Now obj.count is this, and if you want to change it anywhere in the program, or suppose I'm using this here, let's remove the comments of this void display, and let's try to change it within this method, that is underscore count is equal to 9. I want to change it, so it will give error. Let me just run this and show you what error you will get here. Cannot assign a value to a final variable count. It is a final variable. If it's not final variable, let's just delete this final. And now in this method, within this method, I'm going to update this. I'm going to reinitialize this. Let's run this and I'll show you. This time, okay, variable roll number cannot find variable roll number in 10. Okay, we have just commented out this roll number. So let's uncomment this. Let's remove the comment of next roll number as well. And let's just take roll number is equal to 22. Now let's run this. Save this and run this. Variable A. Okay, we have deleted this A. So let's comment out this line also, A also. Let's run this. See, it will give you 8. Why 8? Because control will go here and it will execute this line only. We have commented out this obj, this display function. We are not calling this display function. So let's uncomment this. And now we will call display function. And now the count would be 9. So rather than here printing A, let's access the count. So count is equal to this. Let me just show you now. At first you will get count 8, and next time you will get count. At first it was 8 and next time it is 9. So it's not final, it's not constant. But if you make it constant, then you cannot change it here. See the red line. Cannot assign a value to a final keyword. So this is what a constant is. Now we have made this constant. But generally we make constant to like some pi value or max value in a program, or I have told you the example as well. Right? So this is how we can declare constants in Java using final keyword. Right. So next let's discuss what are literals. I have discussed this also, like simple when we're writing int age is equal to 10. So 10 is or 21 is literal. So literals are fixed values. These are, it's not like that we call these constants. Constants, I have told you what are simply constants in Java. Somewhere somewhere you find out that they known as these are constants, but that's not precisely these are constants. These are basically literals. Although the value is fixed, so we can call somewhat constant, but not those constants. Literals are fixed values that appear directly in the code, in the source code. They can be assigned to variables, used in expressions, and do not change during program execution. So if I write something like this, int age is equal to 21. So this is what a literal. Obviously, this is fixed value. You can directly assign this value to this variable and this 21. 21 would not be changed. Although if you do age is equal to 22, means the variable value has been changed. It's not like that 21 becomes like 22 actual value. Actual value of 21 is 21, but now it's 22. Age becomes 22. In this context, you try to understand this thing, right? Okay. So there are different type of literals in Java. So we have integer literal and floating point literal. So these comes under numeric literals. Integer means whole number, it's negative or positive or zero. Floating means having decimal points like this, right? Now basic difference is what? These are float. In floating point we have float and double. So if you write something like this, like 3.14, so by default compiler consider this as double. Any floating number, by default compiler consider this a double number, double data type. There are two data types. We'll discuss this in float and double. And if you want to consider, if you want to specify that this is a float, not a double, so you have to specify at last f, either capital F or small f. Then compiler will consider this as a float number. What is the difference? For float, less memory would be allocated in the computer memory, less space. For double, more space would be allocated. So if you want to store less short number, not a very large number, you can make it float, or for a large number keep it as it is, like it by default it would be double, so don't keep here f. Okay, so these are float and double literal also. This is float and this is double, so these are floating point literals. Next comes to character literals. So there we have character literals, means a single character. If we assign, like if I write here cat and choice or something is equal to a, or if I write here char grade, your grade is a. So in single quotes, a single this is single quotes, whatever you write, that is a character literal. Or write here one in single quotes, that would also be character literal, not integer, because you have put here this one in single quotes, so this would be considered as, you can say, character. Okay, if you write down here something like this, like slash n, some backslashes are also in character literal, right? So slash n, it is character literal. Slash t is for tab, this is also character literal. There are more backslashes also, those comes under character literal. String literal means, like Jenny, if I assign string name is equal to Rahul, in we write string in double quotes, so this Rahul is nothing but string literal. We call it simply string, but if we say more precisely, then it is string literal. These are fixed values, right? Any values, 10, 20, name of anything, or this. So different type of literals are there. But in double quotes, if you write this is also string literal. In double quote, if you write single a, this is string literal. This a is character literal because it is in single quote. So see, focus this thing. You have to differentiate character and string. Even though it's a single character, but it is considered as string literal because it is in double quotes by the compiler, right? Now these are basic, but more literals are also there. In Java, true and false, these are not keywords, these are Boolean literals. So we can use these also. I will show you how to use in data types. Boolean is also a data type in Java, primitive data type. Like bool we have in, I guess in C++ we have bool. It will take two values, either true or false. So same Boolean we have, true and false. These are Boolean literals. We cannot use this true and false as a name of a variable. Although these are not keywords, but still we can not use these name of a variable because these are Boolean literals, right? Now, like is correct is equal to true. Like this, we can use these Boolean literals, true. Okay. Now, first you have to write like Boolean here. This would be same line Boolean, then name, then the value. Boolean is data type. Null literal is also there in Java. It represents absence of an object reference. This is something different. If you don't want to go into that much deep, you can just skip this. It is not these kind of literal. It is, it comes under reference, object reference, right? Java basically we have two types of variables, primitive and reference variables, right? So now let me show you this thing first. So I've told you like this 22, this is integer literal. If I write here like string name is equal to Rahul, this Rahul is string literal, right? If I write some character char and this that would be character literal. But if you want to assign, like let's use null literal here, like int roll number or this. Suppose here I want to don't just update this. Let's take int a is equal to null. That is not allowed because see maybe you say that here I'm using integer literal, here I'm using string literal, in float I'm using float literal. So let's make this null, a is equal to null, but it will not work. It will give you error. See, required type is int, but you have provided null. It is a type null. Okay, you cannot do something like this. So null basically I told you represents absence of an object reference. Object reference. Now see, in Java, string is not a primitive data type, not built-in data type. String is reference data type. Reference. I in variables also I have discussed, I have told you here in variables. See, variables I have told you basically are of two types. Primitive and reference. This is little bit in deep about variables. If you don't want to go into that much deep, it's okay. Till now we have considered what are variables, that is fine. That are primitive. See, like primitive data type, we have int, float, double, boolean, character, char, and these are primitive data type. So if a variable stores some this kind of value like 10 or 10.1 or a simple character like a, or like if we write here f, so that variable is known as comes under this category, primitive category. Reference means when you are creating object, suppose student is a class and we are creating obj that we have created, and this thing we have written new and the name of that class. This is basically constructor. So this a obj basically, obviously this is, you can consider, you can map this something like this, int a is equal to 10. A is name of variable, int is the type. Here student is the type, but type here is class, and we have defined this type. Obj is name of that variable, but this obj comes under a reference variable. Reference means, see, this a will store the value. In memory we have a, and there the value is stored, that is 10. So this will store some value. Float also some value would be stored. For character also that value would be stored, right? And for double also that value would be stored. But here this obj is a variable, but this is reference variable. Why? Because this will store the reference of this object. In memory we have created some block of memory according to whatever, in student we have whatever the members, and this obj is just reference, just pointing to this memory block. There we have, like in student we have name of the student, roll number of the student, right? Or not name, let's take just roll number and marks, and both are like int and float. So some value would be assigned. Int will take 4 byte, like float will take 4 or 8 bytes according to that specification we'll see. So the total memory would be assigned here, right? How many bytes? That would be according to the members that class have. So this object obj is just a reference, just pointing to this memory location. It's not actually the containing the value. So it doesn't come under primitive variables, it comes under reference variables. So if you are creating object of any class, then that variable would be reference variable. Okay, I hope you got this. So null is also that kind of thing. Null represents absence of an object reference, like this. Let me just show you. Now see, for int a we cannot write down here null, but if I write here string name, or let's take here null, this is fine. This is fine because string is actually a reference data type. It's not primitive data type. So name is what? String is basically a class in Java. Name is basically we are creating object of this class, right? And that's why this object will contain the reference of whatever is here. And null means there is no reference. So null, in this case we can use null, but for integer, for character, we cannot use at the right hand side null. Right. Now let me just show you. For this also, let's not create an object. Let's keep it as it is, or let's is equal to null. So see, dereference of obj. We are now dereferencing obj dot count. We want to access this count using obj. But this obj, this dereferencing of this obj will produce null pointer exception because it is representing by, it's like absence of an object reference. This object, yes, we have created a variable or object of this type, but no memory has been assigned. It is pointing to what? There is no reference. It's null. It's not pointing to any memory in the computer's memory. And if you leave it blank, then also you will get error. It's not like that you have created an object something like this. No, memory has not been assigned. Same error you will get. Variable obj might not have been initialized. You have to initialize this, and how to initialize is equal to new and student. Now it will work fine. Okay. So you can leave this. If you're not getting what is null and all, you can leave this because it's not that much needed right now. Later we will use this. But if you got this, then it's well and good. So you try to use this null at different times in your program, in method or here or something like this. Okay. Or you can use boolean also. I have told you true and false. These are boolean literal. So you cannot use these as a name of a variable. Suppose I want to use int true. It will give you error. Unexpected token. If you want to assign like 8, int true, unexpected token. So it will give you some error. See, at line number 5, Java identifier expected. Identifier means name of the variable expected. True is not a name. You cannot use this true or false. If capital T, this will not give any error. This will work fine. But better to not use these kind of name for variable declaration, right? For boolean, you can use something like this, like boolean and name of the variable I'm taking, suppose, is correct, is equal to true. So this is I'm using boolean literal at this time. This is boolean literal. Is correct is the name of the variable and boolean is the data type. So if you print this is correct, suppose here, so I want to print this within this display method, and let's just call only the display method. That's it. Are we using count here? No, we are not using count underscore count. So let's comment out this line, right? Let's run this and see what output we are getting. C is correct is true. So it is printing the value, Boolean literal value, right? So you can use the Boolean literal also in this way. Although you cannot use like int roll number is equal to true. This will give error. The required type is integer and you are giving a provided is Boolean. This is not allowed, right? This is like mismatch in the data type. This thing we will see next lecture. What are data types? Because this is all about variables. Now I hope you got what are literals, variables, and expression also I have discussed. Like this kind of thing, if you write this is what expression, which is going to be evaluated to a single value, then that is expression. So I hope this is clear to you. This these are simple. We are using these. I hope you got this. If you're not getting this null, you can just skip it for now. Boolean are also simple. Okay. These are basically, not just primitive. These are in case of like objects kind of thing. But I hope this null literal is also not that much tough. Expression also I have told you. These are combination of some variables. Okay, sorry. Combination of variables, operators, values, method invocation, and that would be evaluated to some single value. Like these are kind of expression we can use. This is also an expression. Is correct is a suppose a variable, Boolean variable. Is Java fun is also a variable, and we are combining this with the help of this as an operator, logical and operator. We will see operators. So this will evaluate to a single value, right? How this evaluation would be done? If a little bit I tell you, then suppose is correct. This is true. We have declared this true. This is Java easy. This is false. So true and false would be false. Logical and. For logical and, the truth table is if both values are false, 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 then it will give you false. If both are true, it will give you true. If any one is false, false, true, true, false, then it will give you false. This is truth table for logical and operator. Don't worry, we'll see this later when we'll discuss all the operators. So these are just expressions in Java. We have seen how to initialize variables with literals and expressions. So with literals, we can initialize with something like this. Simply age is equal to 25. So this is integer literal. This is double. This is string. This is character. This is Boolean literal. This is how we can initialize with expressions. This is correct. This one is also correct. Suppose at first, obviously you have to initialize these variables like int a is equal to 10, int b is equal to 20. So this is the expression. 10 plus 20 would be evaluated to a single value 30, and that would be assigned to sum. Boolean is result is a variable. Age greater than equal to 18. Suppose at first in my program age is equal to 17. So 17 greater than equal to 18? No. So this would always be false. This is how we can use expression and literal to evaluate. Now you have to practice some variable declarations. So declare a variable named count. Also declare and initialize a double variable pi. Declare a Boolean variable named is Java fun within a class. Let's modify this within a class. Any class name you can take according to you. Maybe your name you can take as a class name. So these three would be the variables there, right? And you just call a method display and just display all these three values. Okay. With the help of like creating object of this class. This is for your practice assignment. You have to do this thing. Right. Now, next is same, you have to practice variable reinitialization as well. This thing I have told you. First we have initialized, then again we have reinitialized. And then we can print the value of x. You can practice this thing also. You have to practice these things. Now next thing is identifier in Java. So till now we have discussed keywords, variables, constants, literals, expressions. Last is identifier. Identifier is nothing but name of a variable, whether it's name of a class, name of any method. Name of these things are called as identifiers. Identifiers means used to identify something. My name Jenny is an identifier for me. It identifies me that I'm Jenny. So identifiers are names given to various program elements such as variables, methods, or classes or constructors. Also, we'll discuss. So, name of constructor. Those are identifiers. Just to uniquely identify the program elements. Why we name variable? We have discussed why we use variable names. Scope include names of variables, method, classes, and many more things. These are identifiers. Importance is increase the code readability and maintainability of the program. This thing we have discussed. These are related to the variable name we have discussed, nothing else. But simply variable note is not just an identifier. Identifier is name of variable, name of class, name of method, name of any constructor. These are name of any interface. These are identifiers. There are some naming rules also for identifiers. Same as we have discussed for variables. Same naming rule. Characters are allowed. Same. A to Z, 0 to 9, dollar and underscore. First character must be either letter or dollar or underscore. First character cannot be a digit. Length, there is no limit on the length. Variable name length can be anything, any number of words you can take. But generally, we keep short and descriptive name like age or student age rather than writing a long variable name, right? No white space are allowed between words, and identifiers are also case sensitive. Okay. Now that's it for today's class. I hope you got whatever we have discussed. So now you have to practice. You have to practice of all the variables, declaration and all. Don't go into that much deep. We haven't discussed data types. In the next class, we'll discuss data type, different type of data type. Then you can do some more practice. But for now, you simply use int and float. You can use this thing for declaring a variable or simply use int and how to assign, how to reinitialize, what is instance variable, how to define local variable. If I use static, then what would be the effect? If I use final, then what would be the output? So try to use these things. Try to reinitialize the variable. Try to use keywords for a variable name. Try to violate the naming rules of the variable name and then see what error you are getting. Right? So you have to practice now. Practice will make you perfect. Right? Once you practice, you will face many errors and then you will be habitual of seeing those errors. And by looking at those errors only, you will get to know that, okay, this is the error. This is how we can correct this error. So it's better to face more and more errors at this phase only rather than facing when we are actually writing the logics for large programs. Okay. So now that's it for this video. Now I'll see you in the next video. Till then, bye bye. Take care.